are going to run through how to move from rectangular into polar form using the Casio calculator. All right, so first up, just make sure your calculator is in degrees mode, because I'm going to deal with degrees mode first and do radians in another video. You're going to enter the A and the B, the real and the imaginary part, into the calculator. So for 1 plus root 3i, it's 1 and root 3 that you're going to enter into the calculator. All right. You're not going to enter the I, so the real part, the imaginary part. Okay. It is this yellow POL for polar that you're looking for. So if you do shift plus, this should come up, and then it's 1, and then you're going to enter the imaginary part, the root 3. So you're going to do that after a comma. Okay, so shift and right bracket, and then your root 3. Right arrow just to come out from under that square root, then close your bracket, then equals. There's my modulus of 2, there's my argument 60, so 2 cis 60, 2 cis 60 is the answer I expect. All right, so I'm just going to run through the 4 examples that I would have done by hand in a previous video, so that we see one done in each of the 4 quadrants. Okay, if you think you have it from that's great, but just do stick with the video, because there is a couple of little quirks on the way the calculator displays these that I'm going to cover off in 2 of the examples later. So next one of these is one of the ones which has one of these little quirks, which we'll see in a second. So express -3 plus 3i in that form. Okay, so again, we're going shift and plus, enter the -3, shift and right bracket for comma, 3, close your bracket, and equals. And I'm expecting 3 root 2 cis 135. Something's up with the modulus there. I'm not getting 3 root 2, but I am getting the 135. So in degrees mode, it's always going to do the angle right for you. It's just the modulus which might be not displayed the way we want initially. So the 4.24 is correct. That is 3 root 2, but we don't want to write it as 4.246. We want to write it as a surd, not as a decimal. All right. And whenever you write something as a decimal like that, you are rounding off. You are losing a little bit of precision. So we want to write it in surd form. You could just write down 4.242640687, then square it, and then square root it, and that will get you to 3 root 2, going to force it to be in surd form. But the easier way to do it is the calculator has committed the or and the theta to its memory, okay, but it's maybe not too clear where to find them. Okay, it has stored the or, the modulus, as this red x here, and it has stored the angle as that red y there. We don't need to worry about the angle for now. We will when we're doing radians, but it's this red x I'm looking for. So that's the 4.24 committed to the calculator's memory. So I want to get that x up, so it's in red, so it's alpha that I press, and then the right bracket, and I see the x up there, press equals, and it defaults to showing it to me in surd form rather than the 4.24. Okay, so if you get a decimal for your modulus, just do that and it will force it to be a surd for you. Okay, just 2 more examples. So first one, 2 root 3 minus 2i. So we're shift and plus for polar, and then 2 root 3, right arrow to get out from under that square root, shift and bracket for the comma, minus 2, close your bracket, and equals. And 4 cis minus 30 is exactly what I would expect. 4 cis minus 30. So it's done that one correct for me first time round. All right. Last one that I'll do then, and it's another one where the calculator is going to just display the answer not exactly the way I want first time round. So it's minus 4i. So shift and plus minus 4 comma minus 4, close the bracket, and equals, so if the modulus is not the form I want, but if we just look at the angle, the minus 135, yep, that's what I want here. It's 4 root 2 cis minus 135 is the answer, which is just slightly cut off down here. So the angle is fine. The angle will be fine in degrees mode. It's just the modulus it will throw up a little bit strange sometimes. So same thing. It's in the calculator's memory as that red X. And once we get that red X up on its own, it is going to change into certain form for us. So alpha, right bracket, equals, and there's our 4 root 2. So 4 root 2 cis minus 135. Okay, so we saw there the calculator was fine in these two quadrants down here where the angles are negative. It gives us negative angles, so the calculator is programmed to do that. It will give angles up here as positive between 0 and 180. It will give angles down here as negative between 0 and 180. You don't need to kind of mess around like you maybe do a little bit when doing these by hand. The calculator will spit out the answer you want, bar that little quirk with the modulus sometimes.